Today we work in a multi-CAD world, challenged to import and edit the data regardless of what software created it. How often do you find that you get supplied models from other companies that is designed in different software and then having to work with it? Always a difficult situation, especially with the limitations of feature recognition. So in this case we're working with a chassis design, and we've got three components that we're bringing in from other systems. So when we click open, you can see that Solid Edge can work with multiple file formats. Obviously the Solid Edge documents, its sister product NX, and then we have the general universal formats such as Parasolid, Step and IGES, and then we can import data from other systems such as CATIA, Inventor, Pro Engineer, and in this case SolidWorks. So all we need to do is open it and specify the type of file it's going to be. In this case it's just a normal part, and it comes in as a dumb solid, no feature history at all. So what can we do with it? Well, for a start we can just specify that we want to make it steel. That way we're able to work with weights and so on for the assembly. We're also going to specify that it's going to be orange painted. So what else can we do? Well, let's have a look. If we click on a face, Solid Edge with Synchronous Technology is intelligent enough to work out that there are other collinear faces and connected faces, and it adjusts them all together. So let's turn that off. But what if we want to work with dimensions? Well, let's have a look. If we click on here, we're recognizing that this is a cylinder and it's a 6mm hole. Notice as we change the diameter of it, it's picking up that there are other holes of the same diameter, and it adjusts those as well. Of course we can turn that off if we want to. We can also add our own dimensions. Obviously when you're designing something you need to know what the sizes are. So let's place that, and again we can adjust the model through that dimension. In this case we'll make it 6mm. One of the nice features of a history tree is that when you come up against rounds that have been generated in the wrong order, we can end up with a disjointed blend. Here some of them have been done okay, but some of them haven't. So how do we deal with that? Well, in Solid Edge it's as simple as a right click, real or rounds, and we can adjust them nice and easily. While we're here, let's have a look at changing this. Again, Solid Edge is intelligent enough to recognize that the top edge is all one round, 1mm, but it's also recognized that there are other 1mm rounds on here. If we want to, we can change all of them, or we can just change some of them. In this case we're going to change them all to a 1.5mm radius. Nice and quick and simple. Okay, these cylinders are all well and good, but what if we decide we needed to change them? We want counterbores instead. Well, Solid Edge gives us tools to manage that. As you can see here, we have a recognize hole feature. In this case, counterbore at the top, and it's recognized that these are now 5mm diameters, which we changed earlier. But let's change it to a counterbore. Simple, easy, and done in a flash. So, what are the other advantages of having history based? Well, sometimes you may want to delete features. That's simple as well. Let's just highlight the area that we want to delete, deselect faces. You can see now that we have the rounds and the ribs. Simple. Let's just go in and delete them. So Synchronous Technology gives us a lot of flexibility on how we can deal with changing geometry on imported models. Let's stop there, let's save it and place this into our assembly. So insert component and just drag it in. So all we want to do at this stage is align it. Wrong way around, so let's just flip that, and I just want to move it out until I can position it correctly. So the next model that we have is in parasolid format. Again, we just do an open sheet metal component. Once again, we'll give it a material type, and at this stage all I want to do is save it. We have been given the dimensions, 2D working drawings for this in AutoCAD format. So let's just open that up and have a look. So as you can see, we've got layers. We can turn those on or off if we want, just like in a normal AutoCAD file. But wouldn't it be useful if we could actually utilize these dimensions? We've got tolerances on here which may not necessarily be picked up. So let's just use our command to create 3D. In this case, we've already specified that we want to use that model that we've just created, and then it's just a case of simple fence selection on the views that we want to bring in. So as you can see, it's brought it in. Not quite in the right place. So again, we can use our steering wheel, which you saw earlier on. We can move it around in a plane, and then I can just drop it down to the right height. So we can overlay it over the model. So as you can see that it's matched up quite nicely, as you'd expect. Let's just hide those sketches. But wouldn't it be good if we could utilize these dimensions as well? That's simple. Just right mouse click and it attaches those in. Just to prove that, we need to make a couple of changes to the model. Let's just click on this dimension. As you can see, as we scroll, it's changing both legs. And we also want to adjust this down as well to fit the RHS that we're working with. So there's our model and changes completed. Let's just go in and place that into the assembly. Just using our standard relationships. Let's just make that one, and we want to make that hole, align that hole there. Now that we've got that in place, we can use our assemble command and just align these holes up to fully constrain that. So there's one more piece to put into this assembly, and that's a motor. Again, we're going to bring in a foreign part. This one was designed in Inventor, and let's open that up. So that's the model we've been supplied. The one that we're actually buying doesn't actually have this component in here, so we'll just fence select that, and again delete and save this and place it into our model. Once again, we can do an axial align, we can do a face mate, and align the keyways. So we can see now that although we've using both these parts, the flanges don't match up, so we're in a little bit of a pickle here. So let's just go in and edit this. Let's show our assembly, and all we want to do is just utilize that geometry there to rebuild our flange. Done nice and quick. Let's close out, and now we have an ideal situation where we can match those up. One of the things that we possibly will struggle with is the size for the fittings. So let's just change our selection mode, and what we can do is we can do a fence selection and just increase that throat size directly from the assembly. Let's just increase that by 20 mil. And then what we can do is, if we adjust the other size here, we can actually adjust the position of two flanges. So the flanges from a SolidWorks file, an Inventor file, both from the assembly at the same time. So that is the power of Synchronous Technology, easily adjusting imported geometry as easy as if it was in Solid Edge.